what places should we look at? We're trying to figure out which one's the function, which one's the derivative, which one's the second derivative. What types of points should we look at? We can't. Don't get lost in the whole thing here. Look at specific points. What's one specific point, or what's happening at one specific point that would be helpful to look at?
Y equals 0.
What?
When it's 0, when the slope is 0.
When the slope of the tangent line is 0. So let's look at A, just because that's the highest one up here. Let's look at this point, right there. What's the derivative at that point? 0. So if that was the function, if that was the original function right there, if that was the position function, the velocity would have to cross the x-axis right here. So is A the position function?
No.
No. Can it be the velocity function? If it was the velocity function, what would have to cross right here? The acceleration. Does anything cross right there?
No.
So what does this have to be?
Acceleration.
This has to be the acceleration. It has to be. It has to be. Because it can't be velocity or position. So let's change color here. Let's look at this hump right. See this one right here? Go straight down. Is there something right there?
Yeah.
Yeah. So what does it look like? So if it means that, what's the slope here? It's 0. So its derivative better cross there. So what does it look like B should be? Velocity. Exactly. And then that leaves this one with being position. So what else can we do for analysis just to see if that is actually true? We'll take a look at this. If this is the position, what's the slope always look like it is? It's always positive. It gets steepest. Where does it get steepest? It looks like it gets steepest right here, right? Looks like it gets steepest right there. And is that the highest the velocity gets? Yeah. So does this work? It does work. It works nicely. And look what happens here. This right here, we said is the acceleration, the velocity graph. It looks like it's steepest right here. What happens at that steepest point? Oh, look. It gets to its lowest acceleration. Break it down in pieces. Break it down in pieces. So let's go back and look at the one that looks like a little bit more. Look at this one right here. Right there. Oh, sorry. See that right there? Does it look like something is directly below it?
Mm-hmm.
Yeah, it really looks like it. So if we know that's the second derivative, what is this one probably going to be? The first derivative. So this one is the first derivative. So what does that leave us with?
F.
This being the
function.
The function. So if that's true, though, let's just take a look to see if it fits. It looks like the slope of the tangent line right there is 0, right? Go straight down. What do you see?
0.
Zeros. Match these by studying where the tangent line is horizontal, when the derivative is 0. Match them that way. That is the easiest way to do it by far. Minus high d low all over
Low square.
low squared. Let's clean this up first and end up with 2x minus 2 minus 2x minus
Nothing.
1. Right? Yeah.
Oh, yeah.
All over x minus 1 squared. What cancels? Those cancel. It's not plus 1 because the negative goes in there.
5.
So you end up with g prime of x is equal to negative 3 over x minus 1 squared. You can use the quotient rule at this point, or you can just write it as negative 3 times x minus 1 to the negative 2. Because now, what does that tell us the second derivative is? 6 times x minus 1 to the negative 3. And you're all done. Can you use the quotient rule again if you want to?
Yeah.
Oh, what?
Lost a part.
The last part?
We lost a part.
I need to use the chain rule here?
Yeah.
Well, chain rule 1.
Oh my God.
Yes. No, the chain rule comes into play every time, but in this case, it's just 1.
Oh.
It's just 1.
So
Could you use the quotient rule if you wanted to?
Yeah.
Should you get the same thing? Yeah, let's see if it does. It's going to be, so g double prime using quotient rule, so this is quotient. It's going to be low d high. What's the derivative of the top? 0 minus high. What's the derivative of the bottom? 2 times x minus 1 to the first. All over what?
X minus 1 to the first.
Squared to the...
Square.
So it looks nasty, but what that goes away. That's 0, right? Correct?
Yeah.
And it turns into 6 times x minus 1 all over x minus 1 to the... So that's equal to 6 over
X minus 1.
to the third. Is that the exact same thing? It's the same thing. Which one's easier? Use that. Use that one. You can use the quotient, it's theta, right?
Yeah.
What rule do we have to use? Product. Y prime is going to be equal to 1, because that's the derivative of theta, times sine theta plus
Theta.
times
Cosine.
cosine theta. Clean it up a little bit and you end up with sine theta plus theta cosine theta, right? So, second derivative, you end up with cosine theta plus, now you have to use the product rule. The derivative of the first times the second plus the first times the derivative of the second. Clean it up just a little bit and you end up with 2 cosine theta minus sine theta. There it is. That's it. We end up with f prime of t is equal to 6 times 1 minus 7t to the times minus 7. I'm not going to multiply it out. I'm just going to keep it like that. If we do the derivative again, f double prime, you end up with 30, 1 minus 7t to the times negative 7 squared. You have to pop out another negative 7. Do you see why that happens, everybody?
Yes.
Can you clean that up a little bit? Sure, but that right there is fine. That shows me that you differentiated properly. That's fine. Because you popped out a second 7. There's just another one right here. You can write it like that instead. I just squared it because it's easier to write. So, could you keep on going on this? What's the third derivative? 120, 1 minus 7t to the third, and it's negative 7 to the what power? To the third. That's the third derivative, right? Can someone tell me what the seventh derivative of this is going to be? Just stare at it. What's the seventh derivative going to be?
Zero.
I'm sorry, what'd you say?